Let us look at this game in which there are two players, player 1 and player 2. Player 1 has two strategies, U and D, and player 2 has two strategies, L and R. These are the payoffs which are given for both of these players. Can we find out a pure strategy Nash equilibrium? Now supposedly player 1 plays U. In that case, the best strategy for player 2, he has to choose between -2 and 3, so he'll go with this, so he should play R. So when player 1 plays U, player 2 should play R. When player 1 plays D, then player 2 should choose L. Okay, so there is no consistency here. Similarly, when player 2 plays L, then player 1 plays U. He has a choice between 3 and 2, so he will pick up U. And when player 2 plays R, player 1 has a choice between 2 and 5 here, so he should pick up D. There is no pure strategy Nash equilibria in this game. That is one thing. Can we find out a mixed strategy Nash equilibria? Maybe yes. Now, before than this, I would like to tell you something. That is, let us look at this matrix again. Okay, and supposedly player 2 plays L with probability Q, and player 2 plays R with probability 1 minus Q. And player 1 plays U with probability P, and player 1 plays D with probability 1 minus P. Okay. Now, when player 1 is playing U, his payoff from playing U is dependent upon whether player 2 is playing L or player 2 is playing R. I'm again repeating this. When player 1 plays U, his payoff from playing U could be either 3 or 2. But it would be 3 only if player 2 plays L. And it would be 2 only if player 2 plays R. So his payoff from U is dependent upon whether player 2 plays L or player 2 plays R. Similarly, when player 1 plays D, his payoff from D is dependent upon whether player 1 plays L or player 1 plays R. Similarly, player 2's payoff from L is dependent upon whether player 1 plays U or player 1 plays D. Similarly, player 2's payoff from R is dependent upon whether player 1 plays P, whether player 1 plays U or player 1 plays D. Is that okay? Now, for example, player 1 will be indifferent between U and D only if the expected utility from or expected payoff from U is equal to the expected payoff from D. Okay, that's there. But we know this, that expected payoff from U is a function of which strategy player 2 is playing, whether he is playing L or R. Similarly, expected payoff from D is a function of which strategy player 2 is playing, either L or R. Now, when he is playing L, it is equivalent to say he can play L with the probability Q or R with probability 1 minus Q. Is that okay? So it is dependent upon the probabilities with which L and R are being played. Is that okay? Now, let us look at this. So player 1's expectation from U is what? it's his payoff from playing U is either 3 or 2. Now, he will get 3 if player 1 plays Q. So it is 3Q. He will get 2 if player 1 plays R with probability 1 minus Q. So it is 3Q plus 2 into 1 minus Q. Similarly, the expected payoff from D is either 2 or 5 for player 1. Now he will get 2 when player 1 plays L with probability Q, and he will get 5 when player 2 plays R with probability 1 minus Q. Is that okay? That is equivalent of saying that EU is a function of L or R, or the probabilities Q and 1 minus Q. And ED is a function of, again, Q or 1 minus Q. And he will be indifferent between playing U or D when the expected payoff from U or D are equal. So you have found out these expected payoff, and you will just put this equal, and you will get Q equals to 3 by 4. And by that logic, 1 minus Q would be equal to 1 by 4. Is that okay? So player 1 will mix these two strategies if EU is equal to ED, and that's what you have done. Similarly, you guys can look at player 2's strategies. Now player 2 can either play L or he can play R. So we'll have to find out his expected payoff from playing L and his expected payoff from playing R. His payoff from L is dependent upon whether player 1 plays U or player 1 plays D. When player 1 plays U, he plays U with probability P, and he plays D with probability 1 minus P. When player 2 plays L, the payoffs are either minus 2 or 2. Minus 2 will be there if player 1 plays U with probability P. 2 would be there if player 1 plays D with probability 1 minus P. Similarly, the expected payoff from R is going to be either 3 or 0. He will get 3 when player 1 plays U with probability P, and he will get 0 when player 1 plays D with probability 1 minus P. Well, he will mix these two strategies if EL is equal to ER, and you've just put them equal, and you get your P equals to 2 by 7. Is that okay? Now, if you look at this, so what you can say is that mixed strategy Nash equilibrium is you play U with probability P. What is P? 2 by 7 you found out. And player 1 will play D with probability 1 minus P. What is 1 minus P? 5 by 7, and this you have already found out here. P is 2 by 7 and 1 minus P is 5 by 7. So he is going to play U with probability 2 by 7. He is going to play D with probability 5 by 7. Similarly, this guy, your player 2, will play L with probability Q, which you have found out as 3 by 4. And he will play R with probability 1 minus Q, which is 1 by 4. And this is what you have written out here, that player 2 will play L with probability 3 by 4 and R with probability 1 by 4. In the next video, we're going to find out the mixed Nash equilibrium payoffs for this game.